I guess our first set of notes for our Unit 3A is this is going to be all about congruent triangles and whatnot and properties of triangles. We're going to talk about classifying our triangles. One way is by our angles. So here we're going to talk about using, we've already talked about acute, obtuse, and right angles. So we're going to go ahead and jump straight into this. When we have the acute triangle, an acute triangle has angle measures that are less than 90 degrees. So all three will be less. So we're just going to make up some numbers here, knowing that these all are going to add up to 180 degrees. We'll talk about another set of lessons. So let's just go ahead and label 28 degrees, 82 degrees, and 70 degrees. All three of these angles are all acute angles under 90 degrees. So we have an acute triangle. The next, we have an obtuse triangle. With an obtuse triangle, okay, you're going to have one angle, and it'll be exactly one angle that is more than 90 degrees. You cannot have more than one angle of a triangle be more than 90 degrees. It's just the rule. So here, we'll go ahead and take what looks like the obtuse angle here, and let's just call this 110 degrees. So there's our obtuse angle. We see that on a triangle, we call it an obtuse triangle. And we'll label the other ones. Let's just say this is 52 degrees, and up here we'll just say this is 18 degrees. Okay? So there's your obtuse triangle. Your right triangle right here, you should all know what that right angle is. Your right triangle is going to involve, it's going to have one angle measure that is, sorry for the sloppy handwriting, one angle measure that is exactly 90 degrees. Again, you can only have one angle that is 90 degrees in a triangle, and that will make it a right triangle. And so we can just say up here, let's just say this is 40 degrees, and this one over here will be 50, making that those two acute angles also added to 90, giving you the whole 180. All right, but here focusing right now on that 90-degree angle inside of a triangle, we have a right triangle. These all should sound familiar, but now we've got this new thing called an equiangular triangle. Okay, your equiangular, equa meaning equal, angular meaning angle. So this angular part is just talking about your angles. So what's going to happen here is you're going to notice these congruent markings we talked about with angles. They're all three going to be exactly the same measurement here. So we're going to have an equiangular triangle has angle measures that are congruent. See if my purple pen will last. Good. Okay, they're all going to be congruent. And in this, there is a set number, 60 degrees. In every single equiangular triangle, all three angles are automatically 60 degrees so that it can follow your triangle sum theorem that we'll talk about in another set of notes, all adding to 180. This is also going to be an equilateral, equilateral side. So every time you have an equiangular triangle, you also have equilateral. Every time you have equilateral, you'll have equiangular. They go together, right? So we're going to take these and we're going to classify them as either acute, obtuse, right, or equiangular. So when we take a look at the first one, we're going to take a look at our angles. Okay, we're not worrying about the sides right now. We're only looking, we're classifying them by one of these angles. So we take a look and we see all three of these angles are 60 degrees. And we go back up, all of them are congruent. We have equiangular. So this one will be equiangular. I had to remember how to spell equiangular. Let me clean it up for you real quick while you guys are writing it. When we take a look at our next one here, take a look at this. We've got a 57 degrees, we have 79 degrees, and we have 44 degrees. They're not all the same, so it's not equiangular. So we take a look and say, okay, none of them are 90, we don't have any 90 degrees, they don't say 90, and there's not a right angle, so it's not going to be a right triangle. So we're looking at, are they all three under 90, or do we have one that's over 90? And when we look here, all three of these are under 90 degrees, so this will be an acute triangle. Lastly, we take a look at this triangle here, and we see all these markings, these two sides congruent, these angles congruent, but that third angle is not marked congruent like up here. We have a 90-degree angle right here. So this angle right here tells us we have 90 degrees, we have a right angle, we have a right triangle. Then we take a look at the next part. I'm going to outline these in different colors so you guys can see these very clearly. Okay? The first one we're going to talk about is we're going to classify, again, still with angles, triangle U, Y, X. So we're going to go from U to Y over here to X. So we're looking at this triangle right here. All right? And if we notice, we see all three of these angles are all 60 degrees. Not only are they all the same, equal angles, equiangular, but we have that magic number 60 degrees. All three of them are 60. We have an equiangular triangle. Next, we'll take a look at triangle UYZ. So we're going to go from U up here down to Y right here, okay, over to Z. And that's how we're going to name our triangles, those vertices. And we take a look at this triangle right here, we see this 120 degrees, telling us we have one angle that is over 90 degrees. We have an obtuse angle, so we have an obtuse triangle. The last one we look at is going to be triangle UXZ. So we're going to go from U all the way down here to X, all the way over here to Z. Okay, so we're looking for this whole outer thing right here. All right. So I know it's kind of messy, but right here we have a 60 degree, okay, in the triangle. Over here we have this 40 degree. Up here it's not 60, but it's this entire thing right here. Okay, this entire angle right here. So we need to take that 60 degrees here, and this right here is telling us that 43 is up on this triangle. So we're ignoring that. So we have the 60 degrees, and we have what's showing here are 20 degrees. So we're going to take that 60 plus that 20. This whole angle is going to equal 80 degrees. So we look at 80 degrees, 60 degrees, and over here 40 degrees. The three vertices of this green triangle I have. And I notice that they are all acute angles. So we have an acute triangle. They normally are not this complicated looking, I promise. Okay, we give you the more complicated on the notes. All right, so let's talk about classifying triangles with sides. And none of this is new. Okay, you've learned all of this before. So you need to review. We have what's called a scalene triangle. Our scalene triangle is going to have three sides that are not, very, very important, not congruent. So we could just make up three sides. Let's say 5, 9, and 11. None of them are the same. So we have a scalene triangle. Your isosceles triangle has two sides that are congruent. And we look at the picture, we see those markings right here. And we'll learn about why these angles are congruent later on. So we could just say, okay, let's say this is 10. That means this has to be 10. And this third side has to be something completely different. So we'll just call it 7. Okay, so we have two sides that are congruent. We have an isosceles triangle. Then you have your equilateral. Again, equilateral sides. Here we're going to have three sides that are congruent. We saw this on our equiangular, and equilateral is also equiangular, but here we're focusing on our sides, lateral. So we can just sit here and say, no, just call them all three sides 4. So since all three sides are the same, we have your equilateral, which will also be equiangular. So now we're going to take these same three triangles that we had on the previous page, and now we're going to classify them as either equilateral, scalene, or isosceles. So now we're classifying based on the sides. So we look at these different sides here on the first one. What we're going to notice is all three are congruent. And we talked about that. Equilateral and equiangular are the same. So since they're equiangular also, they're going to be equilateral. So all three sides are congruent. Probably shouldn't try to talk and write at the same time. Okay, equilateral, all three congruent sides. Next, we take a look at this one. We have 6.1, 8.7, and 7.4. Not a single side is congruent. This is your infamous scalene triangle. No congruent sides. On the next problem, we're not focusing on 90 degree now. We're focusing on the sides. They didn't give us any measures, but they did put these little markings here. And as we saw up here, if we have two markings, one on each side, one on each of the two sides, we have two congruent sides, and two congruent sides gives us that isosceles triangle. These are going to be vocabulary words that you need to know for this unit. Get out, whatever, flashcards, whatever, to make sure you know classifying by angles and classifying by sides and what the names are. So let's look at actually pulling this into some math here. The example number 4 here is going to say, find the measure of the sides of the equilateral triangle. So what we're saying here is that all three sides are congruent. We want to find the measurement of the sides. Well, once we find out what y is, we can just plug it into one of them because they're all exactly the same. That's what the equilateral tells us. That's what these congruent marks that we just drew in tells us. Okay, so which two, we know that they're all congruent. You cannot have two equal signs. You can't say 2y plus 5 equals 3y minus 3 equals, no, can't do that. You can only have one equal sign. So you have to choose two sides. Which two do you choose? In an equilateral, it does not matter. I suggest taking the smaller looking ones, like here 2y plus 5 and 3y minus 3. If you want to pick two other ones, go for it. You should come out with the exact same answer when we plug back in. Okay, actually even for y. So I'm going to take my 2y. Again, I'm going to go fast through this to make sure that you are pausing. My suggestion is solve it on your own and then press resume and make sure that you got y, you solved for y correctly. So since they are congruent, when two sides are congruent, their measurements are equal. So we're going to go ahead and solve for this. I'm going to move my variable with the smaller coefficient over. So I'm going to get 5 equals 3 minus 2 is only going to give me one single y left, bringing down my minus 3. Add 3 to both sides. The right side cancels. All I have is y equals 8. Now I did want the measure of the sides here. Okay, so make sure we see I've got to substitute back in. Again, guys, don't spend your time plugging into all three of these. We already know it equilateral, all three sides are the same. Choose one to substitute back in for. Again, I always suggest the one that looks easiest. Here's a 2y. That looks like it might be the easiest one. So we're going to take that 2y plus 5. I'm going to remove y and plug back in or substitute in what y is. Let's substitute that in. 2 times 8 is going to give me 16 plus 5. All three sides, since they are congruent, will equal 21. All right. One last one. We're just going to solve for x on this one. Find x. Now we have an isosceles where they tell us segment AB is congruent to segment BC. This is very important. Please pay attention. You will be given triangles that have algebra for all three sides, but it's an isosceles triangle. You have to know which two to set equal to each other, either because they mark congruent markings, or you'll learn later angle markings, or right here it tells us segment AB, so right here AB is going to be congruent, there's your congruent tick mark, to segment BC. BC is over here. It's not always going to be the left and right sides. So you have no choice. You have to choose these two. This is extra information because it is an isosceles. Unless they ask you to find AC, then you'd have to substitute. But here, these are the two that we need. So when two sides are congruent, their measurements are equal. So we will set this equal to each other. 2x minus 7 is equal to 4x minus 21. We'll go through our process. Pause this, please. Solve for x on your own, resume and see if you got the right answer. If not, then go back through and find out what step we messed up on. All right. And here we go. Oh no, don't forget that negative right there. Bringing down that negative 7. Okay. 4 minus 2 is going to give me 2 x's left over. Bring down that minus 21. About to switch colors there. Oh well. Then we need to move that minus 21 over to the other side, which will take care of this negative. Watch what happens. We add that 21 to both sides. Okay, these cancel on the right. We can bring down our 2x. We have a negative 7 plus 21. If you plug that into your calculator, negative 7 plus 21 will give you a positive 14. Then we just divide, last step, divide both sides by that coefficient. X is going to be equal to 14. So this is the stuff you need to know about your sides and your angles, including having algebra on your isosceles and your equilateral triangles.